Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to focus on sequences and series for Mathematics Grade 12, Part 3, which is the quadratic sequence. This is Part 3 of a 4-part series. And in Part 1, we focused on the arithmetic series. You can go watch that video over here to catch up. And in Part 2, we focused on the geometric series, which is basically an exponential function. And you can go catch up on that in this video over here. In part 4, we're going to look at the summary and a list of examples from past exam papers. On that note, please don't forget to click the subscribe button so you don't miss out on part 4 of this 4-part video series. We have a lot to cover, so let's start. In general, in summary, we're going to look at number 1, the definition of a quadratic sequence, number 2, the general term of a quadratic sequence and examples of those quadratic sequences, and lastly, we're going to look at an example from past exam papers. Let's start. The definition: a quadratic sequence is a sequence of numbers in which the second difference between any two consecutive terms is a constant. So the second level of differences, that's what should be a constant. In an arithmetic sequence or series, it is the first level of differences that should be a constant. Now, if that situation that gives you the second difference between any two consecutive terms as a constant, you know you're dealing with a quadratic sequence. And that sequence has a graph of a parabola, which is the quadratic function, and therefore it follows the same trend. Now let's look at the general term. We've got two levels of general term for a quadratic sequence. The first level is Tn equals to an squared plus bn plus c. This is what I call the general term. And then you've got the second level of general terms, which is specific to a term number. For term 1, that will be a plus b plus c. And the general term for term 2 is 4a plus 2b plus c, and so on and so forth. That is the first level of your sequence. Now, the first level of differences is 3a plus b, and then you've got 5a plus b, and so on and so forth. Now, the second level of differences is 2a. Remember, the first level of differences in a quadratic pattern is basically an arithmetic sequence, so don't forget that. That is why this is the constant difference of the arithmetic sequence that is formed by the first level of differences of a quadratic pattern. Don't forget that relationship. It's going to come in handy later. Now let's look at some examples of geometric patterns. You've got all of this. Please pause to figure out the second constant difference of each one of them, just to prove for yourself that we're dealing indeed all of these are quadratic patterns. Let's look at the last one just to give you an example of how you test whether it is a quadratic pattern or not. Got 2, 7, 14, 13, 2, 7, 14, 23, 2, 7, 14, and the last one is 23. So what you do is you find the first level of differences. 7 minus 2, that will give you 5. 14 minus 7, that is 7. And then 23 minus 14, that will give you 9. And the second level of differences will be 7 minus 5, that is 2. 9 minus 7, that is also 2. Here is your second level of differences that is a constant. Therefore, this makes this pattern a quadratic pattern, and that's how you check if a pattern is a quadratic pattern or not. Now let's look at an example from past exam papers. This one comes from the November 2022 Department of Education final matriculant examination, paper 1. Question number 3 says, it is given that the general term of a quadratic pattern, dealing with a quadratic pattern, is Tn equals to n squared plus bn plus 9, and the first term of the first differences is 7. So you have the general term of the quadratic pattern, which has got the following information: a equals to 1, that is the coefficient of n squared, and then we've got c C equals to 9, which is the constant. And then B is what you're trying to figure out. Now, they also say that the first term of the first difference is 7. Now, the first level of difference is the first term is 3A plus B. And we'll see that from the net. Now, we're supposed to prove in 3.1, we're supposed to show that B is equals to 4. In other words, this coefficient of n is equal to 4. Always keep this in mind when dealing with a quadratic pattern. Have this net out handy because it's going to be very handy and crucial for you to use. Now, here is the net that I'm talking about. Here is the net that we're talking about. We're told that the first level of the first term of the first level of differences is equal to 7, and this is what we are talking about. Now, that's 3A plus B. We are told that that is equals to 7. And we also are told that A equals to 1, C equals to 9. We don't need that here. So what we do is we substitute that and solve for B. B equals to 7 minus 3, which is equals to 4. And there, it's proven. 3.2. The next question, 3.2, says determine the value of the 60th term of the pattern. So we're looking for T60 over here. That's what we're looking for. Remember now the general term is n squared plus 4n plus 9, because B is equals to 4. And we're looking for term number 60. That is a question mark there. Now that is very easy to figure out. So that will be 60. You just substitute 60 where there is n. So that will be 60 all squared plus 4 times 60 plus 9. And that will be equal to, take out a calculator. Always use a calculator just to avoid making silly mistakes which could affect the answer you get at the end and therefore mess with your marks. So we've got, okay, so that'll be 60 squared plus 4 times 60 plus 9, and that will give us, that gives us the answer 3,849. So that is 3,849. And that is your answer there. Now for T 3.3, let's remove this net over here. Okay, let's go 3.3. Question 3.3 goes, determine the general term for the sequence of first differences of the quadratic number pattern. Write your answer in the form TP equals to M times P plus Q. Remember, the first level of differences form an arithmetic sequence. So what we do is we list the terms of this quadratic pattern so we can find what the first level of differences is. So that will be 1 squared plus 4 times 1 plus 9. And that gives us an answer of, okay, 9 plus 1, that is 10 plus 4, that gives us 14. Term 2 of the quadratic pattern is 2 all squared plus 4 times 2 plus 9. And that will be equals to, take out a calculator just to make sure that you don't make those silly mistakes we're trying to avoid. So that will be 2 squared, let's move it around, so that will be 2 squared plus 4 times 2 plus 9, and that gives us 21. So that will be 21 over here. And then T3, term number 3 will be equals to 3 all squared plus 4 times 3 plus 9, which will give us, let's use a calculator, 3 squared plus 4 times 3 plus 9, and that is equals to 30. So that's what we have here, 30. Now let's list this quadratic pattern. So that will be 14, 21, 30. 21 minus 14, that is 7. 30 minus 21, that is 9. And the second level of differences is 2. Now, the pattern we are looking for is the arithmetic sequence. This is the level. This forms an arithmetic sequence with the general term a plus in bracket n minus 1 times d. And with our a equals to 7 and our constant difference equals to 2. Now let's find that general term. That will be, therefore, the general term will be 7 plus in bracket n minus 1 times 2, which is equals to 7 plus 2n minus 2, which is equals to 2n plus 5. So therefore, the answer to the question will be t of p will be equals to 2p plus 5. And that's how we answer that question. Next question, 3.4, which happens to also be the last question. Which two consecutive terms in the quadratic number pattern have a first difference of 157? What they're looking for is between which terms in the very beginning, between which two terms, could be anyone, got tn minus 1 and then tn, between which terms do we find a difference of 157? Let's go back. Yes, 157. And that's how basically you set up the question. Now let's answer that question. 3.4. We're looking for the terms that when the difference between the terms gives us, gives us 157. You can use tn and tn minus 1, or you can use tn plus 1 and minus tn. It gives you exactly the same answer as long as we're dealing with two consecutive terms. Tn and tn minus 1 are consecutive terms, so they work well. Now tn, according to the general term of this particular sequence, is n squared plus 4n plus 9, which makes tn minus 1 be replaced. Where there is n, you put n minus 1. So wherever there is n, you put n minus 1. And that is equals to 157. Let's expand now. That leaves us with n squared plus 4n plus 9 minus, let's expand, the square for binomial, n minus 1 all squared is equals to the square of the first term plus 2 times the product of the terms with their signs plus the square of the last term. And that gives us n squared minus 2n plus 1. And that's how you expand that. So let's substitute that here. N squared minus 2n plus 1. And that becomes 4n minus 4 plus 9. And that is equals to 157. 157. All right, let's add like terms. Simplify this. N squared plus 4n plus 9 minus, this will be n squared, or we've got minus 2n plus 4n, so that's 4 minus 2, that gives us 2n. And then we have 9 plus 1, which is 10, minus 4, that gives us 6, and that is equals to 157. Take out the brackets, take off the brackets. First 9 minus n squared minus 2n minus 6, that is equals to 157. Add like terms, n squared minus n squared, that is 0, so they cancel out. Now 4n minus 2n, that gives us 2n. 9 minus 6 gives us 3, so that is equals to 157. Now take the 3 to the right hand side. You're left with 157 minus 3, which gives us 154. Now what you do is you divide both sides by 2 to solve for n. And that will give us, let's take out the calculator. Alright, so that will be 154 divided by 2. And that gives us an answer of 77. So we have 77, 77. That is one term. N, Tn. N is 77, so n minus 1 will be 76. The term before that will be 76. Therefore, before we make any conclusions, let's just check if the difference between the two terms gives us 157. Take out a calculator. Alright, so we go term 77 minus term 76. Alright, let's go. So 77 squared plus 4 times 77 plus 9 minus 76 squared plus 4 times 76 plus 9, close bracket, that will give us an answer of, and that gives us 157. So yes, that is the correct answer. We checked it out, it checks out. Therefore, T77 minus T76 equals to 157, meaning that therefore the two consecutive terms are T76 and T77. And that's how you answer that question. We've come to the end of this video. Thank you so much for watching. I'll see you in the next one. Bye bye.